Hi, this is a short tutorial video on how and why to memorize truth tables for propositional connectives. It corresponds to Gamut Volume 1, Section 2.2, and Sham's Outline, Section 3.4. So what are the propositional connectives? There are 4 connectives in propositional logic. In particular, there is the AND connective, which we write in symbols with a little wedge, like so, or sometimes you might just write an N symbol like that, or if you're typing in particular, you might write an ampersand, i.e. the thing that you get with Shift 7 when you type on the keyboard. The second propositional connective is the OR symbol, which we write with a little caret symbol like that. And the third symbol is the not symbol, which we write like that. And the fourth and final symbol is the conditional, which we write with a single right arrow like that. So those are the 4 connectives in propositional logic. And associated to each of the connectives is a truth table. It's very important when you're beginning propositional logic to spend a couple hours memorizing the 4 truth tables for the 4 propositional connectives. And what I want to do right now is just show you how to draw them. It's important to know how to draw them when you're memorizing them, because the algorithm that we're going to learn for testing validity in propositional logic depends crucially on your ability to rewrite over and over again these 4 truth tables for the 4 propositional connectives. Alright, so now we're going to start off by writing the truth table for the first connective, AND. Alright, so how do we do this? First, we get a nice little Excel sheet going like that. And then what we do is we write let me see, I need to get my pen here. Alright, what we do is we write our first propositional letter, which is traditionally always the lowercase Roman letter P, followed by the Roman case letter Q, and then we write P and Q like that. Now, the truth table for P and Q is just something you have to memorize. And so I'm going to start writing it right now. But you'll see as we're writing it that there's a pattern to how you go about writing it. First, in this entry, you put true, true. This corresponds to the situation in which both P and Q are true. And naturally, if P and Q are true, then it makes sense that you should put true in the P and Q column. The second option after true and true is true and false. And naturally, what you write in the third column is false. Because if Q is false, then certainly P and Q had better be false. Then in the third row, what we do is we consider the other possibility where one is true and the other is false. Namely, we go false, true. And then, of course, the entry for the third column should be false, because if P is false, then P and Q had better be false. Finally, we consider the last possibility, false and false. And, of course, if both are false, then P and Q has absolutely no hope of being true, so it is false. So that's the truth table for the connective AND. And this is just a table that you have to memorize. Now, there's a simple pattern for how you memorize it, and I'm going to illustrate that pattern right now. So let's draw it again. So what I'm going to do now is just rewrite the truth table for the propositional connective AND, but do it a little bit faster. So we have P, Q, P and Q. So then the way you always enumerate the possibilities is as follows. First comes true, true. Then comes true, false. Then you switch it, you go false, true. And then you consider the last possibility, false, false. Now, again, we have that's true, and the other three are false, because the only way P and Q can be true is for both of the components to be true. So that's the truth table for the propositional connective end. Now, in the gamut book, sometimes we write, instead of true and false, 1 and 0. So true equals 1 and false equals 0. So how would we write the table if we wanted to memorize it that way? You should feel free to memorize it whichever way you like. So again, we go P, Q, P, and Q. So we go, again, we enumerate the possibilities here. So true, 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 false. Switch them up, false, true, false, false. Again, the idea here is 1 corresponds to true, 0 corresponds to false. And then, so naturally, it's going to be 1, 0, 0 here on this column. So if you want to memorize that, the truth table for the propositional connective end in that format using the 1s and 0s instead of the true and falses, feel free to do so. Either will be acceptable here in this course. Okay, so that's the that's the truth table for the propositional connective end. Let's now do the truth table for the propositional connective OR. Okay, so get our table back there. And then we're gonna go again P, Q, and now we're doing OR, so P or Q, like that. And I'm gonna do it in terms of the true and falses first. So I do true, 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 false, false, true, false, false. So that enumeration is the same between the truth table for the propositional connective OR and the truth table for the propositional connective AND. What is, of course, crucially different is the entries in this third column. Now let's think about what these should be. If P and Q are true, as in the first row here, then naturally their disjunction should be true. And now, for a disjunct to be true, it only requires that one of them be true. So we put trues in there. And so the only way that a disjunct can be false is if both of the disjuncts are false. And so we have that false goes here. So this is the entry for the propositional connective OR. And again, you just need to memorize that. Let's write it now just in terms of 0s and 1s instead of trues and falses, in case you want to memorize it in that way. Okay, I get my pen tool here. So we have P, Q, P, or Q, and we enumerate the possibilities. True, 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 false, false, true, false, false. I see. And again, we're going to have true, true, true here followed by false. Because the only way that a disjunct is going to be false is if both of the disjuncts are false. So that's the truth table for OR written out in terms of 0s and 1s. Now we turn to the third propositional connective, namely negation. All right. So negation is a little bit different in that it only takes one propositional formula as its input. So what we do here is we put P in the first column, then we don't put Q in the second column, rather we just put not P in the second column. So there is no Q in the truth table for negation. Now, let's do it first in terms of the trues and falses. Now, since we only have one propositional letter, there's really only two possibilities. P can be true, or P can be false. Now, if P is true, then of course not P should be false. And likewise, if P is false, then not P should be true. And that's it. So the truth table for the propositional connective negation is very, very short. Let's write it now just in terms of zeros and ones, just in case you want to memorize it that way. So what we have here is we have P, not P, and first possibility is P is true, second possibility is P is false, and then if P is true, then not P is false, and if P is false, then not P is true. So that's the truth table for the propositional connective not or negation, written out in terms of zeros and ones, where again the idea is 1 corresponds to truth, 0 corresponds to falsity. Alright, so finally we come to the last propositional connective, namely the conditional. And like with conjunction and disjunction, this one takes P's and Q's and returns P arrow Q, which we pronounce as P implies Q, or if P then Q. So let's do it first in terms of the truth and falsities. So let's enumerate them quickly. So we go 4 possibilities. P is true, Q is true. P is true, Q is false. Converse possibility, P is false, Q is true. Finally, both possibilities, they are both false. Now, this is where the virtue of memorization becomes very, very clear, because it'll be crucially important that you just memorize the entries for the third column. And the entries go like this: true, false, true, true. So the only way for the conditional to come out false is if the first part, P, is true and the second part, Q, is false. Sometimes we call the first part the antecedent and the second part the consequent. So stated in those terms, the only way for the conditional to come out false is if the antecedent is true and the consequent is false. That is, the only way for the material conditional to come out false is if you go from true to false, going from the antecedent to the consequent. Okay, and again, you just need to memorize that. Let's write out that table in terms of zeros and ones. All right, so it goes like this: P, Q. P arrow Q, i.e. P implies Q, or if P, then Q. Okay, so we enumerate the possibilities now in terms of zeros and ones, where again the idea is 1 is true and 0 is false. So true, 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 false, false, true, false, false. And again, the idea is the only place where the material conditional comes out false is when you go from true to false, going from antecedent, the first part, to consequent, the second part. So again, here we have 1, 0, 1, 1. All right. So that is the truth table for the material conditional. And again, you just need to memorize that either in terms of the zeros and ones or in terms of the true and falses, whichever method you prefer. Both, again, will be accepted in this course. Again, the Gamut book uses the zeros and ones, whereas the Shams outline uses the trues and falses. After doing a couple exercises with these things, you'll be able to do both very, very easily. But again, at this juncture, what's important is that you memorize things. So what you need to do now is go memorize the truth tables for the 4 propositional connectives, namely conjunction, disjunction, negation, and the conditional.